Okay. Thank you so much, everyone, for your responses. So let's start with the session. Excited? So a very warm welcome to Ritesh sir, who brings more than 16 years of experience, who is senior architect at Three Pillar Global, who is ex VP at Morgan Chase. So Ritesh sir will be our guest speaker of the day. So a very warm welcome to Ritesh sir.
Thank you so much, Srishti, and thank you to Pregrad for allowing me to do this session with so many youngsters who have joined the call today. I hope that this session will be useful for them. And although I would be delivering the session, I also hope to get a few takeaways from this session based on whatever queries they ask me. And let's hope it's useful for all of us.
Yes, sure, sir. So please, everyone, if you feel any queries or anything, please write in the chat box. And requested to all attendees, your mics and cameras are off. So thank you so much.
Right. All right. So I'm gonna get started with a little presentation. I wanna try to make it as interactive as possible because obviously I wanna hear from you guys. This session is about you, and I want you to have the maximum takeaway from this. I'm gonna start with a little base about the AML, why it is so widely in demand these days, about the whole Gen AI revolution as to why it's taking the world by storm, the current job market, current opportunities we have. I'm also going to be talking about the differences between various careers within data science, right? Like, for example, data analysts, data engineers, and so on. So you have a fairly good idea about the opportunities that might be available for you in the market as you graduate, or maybe even if you have already graduated and have started looking for a job. So let me share my screen and do let me know if you can see it or not. Hopefully, you should be able to see it. Um, can you see my screen? No? Are you guys able to see my screen? All right, then let's begin. So this session is, I mean, at least this presentation is about forging a successful career in data science. So just to give you a preamble, it is very important to understand that there is no data science without data. And if you look at data, it is slowly becoming the new oil these days because companies are slowly but steadily starting to monetize their data. They have started to collect data from various sources, and the biggest source of data is, of course, us. We are consumers. We go online every day. We do a lot of activities online, and companies are tracking all of that data and using it to build insights about us. And this data is invaluable. There's all of this data is going into pipelines, into analytic engines, into training machine learning models, and it is a very crucial aspect of any organization's functioning today because the data tells them in structured, it could be unstructured. So structured data is a very good example is data you might store in a relational database. Unstructured data could be something like data stored inside images, tables and PDF files, video files, audio files, and so on. And there are, of course, various tools and technologies to analyze the different sources of data, different types of data. And all of this data in collation paints a holistic picture for an organization, and it also helps it strategize. So anytime you're dealing with any sort of data, it is important to understand and visualize how this data is going to help your organization. In the end, it's all about analyzing the data to see how you can help your organization. That's what it is to understand the data. So let me get to the next slide. Just if there are any questions, do let me know because I am not looking at the chat window. So do interrupt me, and if there are any questions, let me know if someone asking any questions around the slides. Of course, we'll leave some time towards the end for Q&A, but still, yeah. All right. So Again, why is data science important? Like I said, data is the new oil, and all of the companies need this data to create those strategies. So, data science combines various tools, methods, and technologies to generate meaning from data, insights from data, strategy from data. Insights that are derived from this data help the businesses formulate strategy, of course, but also what they're going to be doing for the next few years. Even something as critical as hiring decisions require a lot of data processing. This you would have been reading a lot that at the start of 20, even at the end of 2023, a lot of companies have started firing people, hiring is slowing down. All of this is related to analytics. It is definitely related to data, and the data is telling these companies that to save costs, they need to take care of these. They need to do these restructuring things. So that is why, although it is good to understand the data, is also important to understand the data from your perspective as to how it's going to help you in your career. How is it going to safeguard your career as well? Where is the job market headed? It's important to keep a holistic viewpoint of all of these things. Later on, I'll be talking about how you can kind of inculcate a viewpoint about data that affects you and affects the company directly. And all of this is going to help you in your career. So some very popular data science use cases, of course, are healthcare, marketing, finance, research, etc. There are a few mentioned over here, but one important use case uh, that hardly anyone in India is looking at is research. So, although we file quite a few patents every year, a lot of people from India have been filing patents regularly related to AI/ML and machine learning. But at the same point of time, we don't see a lot of innovation coming from India. I mean, we usually follow the herd when it comes to innovation in data science, and this is a very crucial aspect that we are missing. So even as students, as you are kind of doing your graduate degrees, maybe you go on to do your masters and all. Think along those lines as to how you can kind of innovate in this space of AI/ML and machine learning, because right now the one thing that was holding back any advancements in AI/ML was, of course, the compute power, which has grown significantly in the few years. And today it is so easy to spin up an instance on an AWS, on a GCP, and start training machine learning models. And this is where it is important to experiment as well and come up with innovation in this space. And if we are able to crack that code of innovation, I believe that the future is going to be very bright, at least for us as a country, and overall any organizations and startups that are coming out of India. It will be good for them to do this exploration. Gonna take a quick pause. What do you guys think about use cases in AI/ML? Do you think that over and above this list that I presented, do you think that there are use cases that I'm missing, or use cases that I should be talking about? Anything in your mind? Let me know in the chat, please. Let's let's keep this interactive. So use the chat to kind of add your understanding of use cases that AI/ML can be used for, or how you or where you think innovation can happen in AI/ML. Anything at all. So two people have raised their hands, but I don't think you'll be able to talk. Okay. Education automation, education and research. What sort of research do you think can happen in education? So that's a very interesting point that you've raised. But in terms of education, what do you think we can do with AI/ML? Just a quick summary of what your thoughts are. Definitely customer service. Yes. Let me talk about education. So in general, when you look at education in India, pedagogy, interesting. So if you look at education in India, it's largely attributed towards it's heavily tilted towards rote learning. We are supposed to learn a lot of things by heart. and then go and vomit them in the examinations. But experiential learning is something that is that we haven't explored enough yet. And what I mean by experiential learning is where you actually do something to learn something, where you do some sort of hands-on exercise, where you actually experiment, carry out various experiments and learn. And yes, AI can help us there because you can use AI to build a lot of simulation engines that allow you to simulate a lot of real-world scenarios. Like for example, in you would have done a lot of engineering drawing as part of your curriculum, but then again, these are just part of the curriculum. You don't really understand how those engineering drawings are useful in the real world. So if AI were to give you the opportunity to build engineering drawings, maybe to build roads or build infrastructure and so on, then it would help to understand how it can be applied. So definitely simulations, maybe a little bit of AR and VR, where AI can be used to simulate certain scenarios for you to learn and so on. So there's definitely a lot of application in education as well. I would say there's a lot of application in healthcare because again, as a I mean, not just India, but overall, if I look at the world, I think that innovations in medical sciences has been extremely slow. But I feel that AIML has a lot of answers for us in that space. All right. Uh, Good points there. Let's move on. The next important aspect to think about is big data. So anytime if somebody is going to be talking about big data, they obviously mean things like Hadoop. You would have heard of Hadoop and Spark, and this is nothing but so any organization that deals with petabytes of data, it is processing petabytes and petabytes of data. Uh, when the scale is so large, it is largely categorized as big data. And so there are three V's that signify this category of big data. That is the volume, which is like I said, could be petabytes of data. The velocity, the speed at which all of this data needs to be processed. And we have massive pipelines processing extremely large amounts of data every day. A lot of organizations do this, and there are analytical pipelines at the end of those pipelines. And this needs to be done at a lot of speed. We have a lot of real-time analytical engines also running constantly. Like for example, even if you're watching an IPL match, there is a lot of analytics processing happening at the back end, even as the match is going on live. Uh, I guess you guys would already have an idea about this, but the reason I'm talking about big data here is because it is a huge aspect about a career in data. Simply because processing data is the first step. Processing and understanding data is the first step towards forging a successful career in data science. And then, of course, I've already talked about the variety to be structured or unstructured data. So that is where like big data comes in to build these massive data warehouses and data lakes for organizations to carry out analytics at scale. Of course, the need for big data is in all of these areas. A few pointers like improved decision making. And when I talk about decision making, I'm not talking about the organization looking at a certain aspect of the data. Like, for example, if you would have heard of Google Analytics, anytime you visit a site, Google Analytics tracks your every step as to what you've done on the website. But over and apart from that, there are a lot of other analytics also that happen at the backend side where user touch points generate a lot of data. And all of this data forms a holistic picture, and that holistic picture helps the organization derive insights. Because if you look at data in disparate silos, you will not get the bigger picture. So it is important to combine all of that data into things like data lakes and understand the bigger picture. And if you miss the bigger picture, then whenever you visit any sort of website, the user experience is designed in a certain manner for a reason. Simply because as the user navigates the website, they generate a data trail, and that data trail gives a lot of insights into how the customer is thinking. There's a lot of psychoanalytics that goes into this, so it's like they're actually building a psychological profile of a user that is navigating your website, and you're trying to predict their behavior on the website. And data for this a lot is used a lot to derive these insights. A lot of companies use this data for building a competitive advantage over their competitors. Uh, Real-time analytics, like I said, if you're watching an IPL match, a lot of real-time analytics happens in that case, and so on. So there are a lot of use cases. I'll be sharing this slide with Shifty. You can go over the use cases for big data, but over and above these also, there are so many use cases. Any questions about big data at this point? Anything you guys want to ask or query me about? Use the chat function, please. Anyone else? All right, let's move on and let's get to the crux of this. Oh, skipped a few slides. How would it do that? Uh, yeah. All right. So essentially, what is AI? AI is just the simulation of human intelligence inside machines. I mean, if you look at it in layman terms, this is what it is. But largely, AI was introduced to replace the function of jobs, mundane jobs like data entry and so on. So essentially, it's trying to replace those mundane and rote learning kind of jobs with automation. That is what the crux is. The eventual target state for AI, of course, after having looked at the Gen AI revolution, the eventual target state is going to be complete automation, wherein we as a species won't have to do a lot of work, and AI would do most of the heavy lifting for us. Of course, now this is a very important point, and a lot of people are talking about it. You would have read it on LinkedIn and so on. That will AI replace our jobs? Will AI replace jobs like coding? Will AI replace jobs in marketing? Will AI replace jobs in finance? So it is very important to look at certain aspects of these jobs. So, for example, coding. Now, the thing about when you talk about coding, it's not just as simple as just writing a piece of code to satisfy a requirement. The thing is that a lot of companies have requirements that are fluid, they change all the time. Uh, you are expected to be on your feet all of the time and think out of the box when it comes to any sort of requirement. It's not as simple as writing an if else statement and saying, yeah, our job is done. And so this is where the human touch is required even in coding, because even though AI might write a piece of code, it always misses the bigger picture and the holistic context of a particular requirement. Uh, Over and above that, within coding also, it misses a lot of other aspects like how do users think, how would users behave when it comes for that code to be executing in the bigger context. So what's going to happen right now is that in terms of at least coding jobs, you would have a lot of AI assistant coding tools running. Somebody mentioned Copilot. So a lot of companies are going to be deploying those tools for you to use, but there is going to be a acceptable use policy for those tools as well. One, you would never be allowed to copy paste the code directly from any sort of tool into any production environment simply because the code that AI generates cannot guarantee security. Uh, it is prone to making mistakes like hallucinations. So obviously, even if somebody takes a code from a tool, they're going to have to go through it with a fine-tooth comb and make sure that it does not leave any loopholes in it, and also it satisfies the requirements. So testing is going to be fairly important. So coding jobs are not going to be affected. Jobs in marketing. So yes, there are a lot of tools, and I've personally worked on one tool myself using Gen AI. A lot of tools that allow you to generate content, to do analysis of your competitors, and so on. But those tools are only as good as the knowledge base that is provided to them. Over and above that, they have a tendency to hallucinate. Uh, they don't understand human emotion, and things like marketing and ad generation and so on need to understand human sentiment. So uh, they would never AI machines would never understand that human sentiment and the human emotion. It's going to be very hard for them to get to that point. It would take years for that to happen because marketing and advertising is a very creative field. So those tools are definitely going to help marketing teams and advertising teams gather insights about competitors and so on. But again, they would just be tools that those teams would use to generate campaigns, generate strategies for marketing, and so on. So again, uh, a lot of functions like data gathering, for example, writing crawler tools to crawl competitive websites, to check for SEO keywords and so on, those can be automated using AI. And if certain people are performing those functions, like for example, interns writing crawlers to crawl certain websites, all of that can be automated and those jobs might go away. So a lot of data entry jobs will also go away, especially in marketing. But what will remain is the creative aspect of it, like generating graphics for ads, generating Sora has come in, so generating ad films would be assisted by Sora, but again, it would not be completely delegated to Sora to create a complete advertisement and so on. And finally, in the realm of finance, again, even in finance, there are a lot of nuances because there are a lot of compliances, there are a lot of laws that are applicable to a certain country. That only and this law has very complicated verbiage in it. It's very important to understand the language. There are a lot of ambiguities in legal terms as well, which AI would not be able to understand for the most part. So again, a lot of jobs would not go away in finance as well due to this reason. But again, tools would be built to assist people, and again, jobs that can be automated would go away due to AI. Um, any questions related to this at this point? Because you people are going to be heading into the job market, so it is important for you to understand what sort of jobs could be at risk. Any questions? Anything you guys want to ask me? Do testing jobs have good future? So again, a lot of testing jobs will go away because of automation. Very simply, let's say that you want to write a unit test for a particular piece of code. There can be a tool to generate the unit test, but again, as to the quality of the unit test that is being written, you would still have humans intervening there. But if you tell me that there is a website that you want to crawl or you want to test certain links on the website, all of that can be automated by AI tools. Those sort of jobs would be affected. Manual testing jobs would be affected. If somebody is doing just manual testing and not at all looking at automation, then those jobs could be affected. So yes, testing jobs would be affected if it's manual testing. If it's simple point and click kind of testing jobs, if there is normal automation, like for example, if you're writing a Selenium test, just writing a Selenium test to check a website, that kind of those kind of jobs are going to go away because those can be generated by AI. Uh, but user acceptance testing, A/B testing, all of that would not go away for sure. What kind of jobs will be there in the market even after proper advancement of AI tools in the market in the software fields? Like I said, lower function jobs are going to go away, like data entry, data crawling, some kind of data analysis jobs wherein you just take two, three data sets and check the covariance within the data sets, or maybe do a standard deviation analysis. If you're doing all of that, those jobs are going to be taken away by AI for sure. But if you're performing over and above that, if you're doing a lot of other stuff, like for example, if you're comparing data from multiple sources and then adding a human element as to, let's say, you're capturing clickstream data as to how users are clicking on your website and then using that for analytics, AI is not going to be able to analyze all of that. So wherever there are multiple data sources, all of them are collated, merged, and then some data analysis is done, that cannot be taken over by AI. But if it's a simple job like writing an SQL query to fetch data from a table, those jobs will go away for sure. Any other questions? Okay, looks like I'm satisfied with curiosity. Excellent. Keep asking questions. It's going to be helpful for me as well. What is the difference between AI and ML? So, of course, the slide mentions that, but if you look at it, ML is just a subset of AI, and machine learning just an application of AI. Of course, machine learning has a lot of offshoots as well. There's classical machine learning algorithms, there's deep learning, and so on. And even within ML, there are a lot of specializations. So, even as a data scientist, you might end up in a job where you're specializing in a certain area of data science. Like, for example, you might specialize in image processing, like using tools like OpenCV, object detection, and so on. Or you might specialize in NLP, where you might work with Gen AI. You might work on recommendation engines, like, for example, building shopping carts with recommending engines for shopping carts and so on. So, when it comes to AI, it is important to understand the fundamental concepts of AI, but over and above that, machine learning is just an application of AI in practicality. That is what it is. And a very important offshoot of machine learning has always been deep learning. So if I look at deep learning, then it has a lot of applications in data science, and the biggest application that you're looking at today is, of course, generative AI. So the evolution of deep learning has been quite interesting. I mean, even in the 1960s, people had started exploring the concept of neurons, basically, which is nothing but how the human brain functions. And then the most basic unit of deep learning was a perceptron, which had one sigmoid kind of activation function, and then you had a couple of inputs and it would output some sort of classification. And slowly but steadily, as machines became more and more capable. Uh, we had multi-layered neural networks where you had the concept of hidden layers, and the biggest evolution in deep learning came because of the concept of backpropagation. And backpropagation is nothing but it's always you kind of adjust the weights and biases within the hidden layers of a neural network to give some sort of output. Of course, there are a lot of deeper concepts to understand within this, but just in a nutshell, deep learning is nothing but a simulation of how the human brain works using certain mathematical concepts. I'll be talking about what mathematical concepts are important to understand, but a lot of calculus is used, a lot of linear algebra is used to understand the concepts of deep learning. And it is important to understand these concepts because uh, when it comes to the field of data science, it is important to build some sort of intuition on how to deal with certain kinds of data, structured and unstructured. And that intuition is built if you understand the basic fundamental mathematical models that are used to create these kind of networks. There are several applications of neural networks that are mentioned over here, but as we go along, I think you will understand better. Uh, Various kind of deep learning neural networks are like convolutional neural networks that are used for image processing, recurrent neural networks like LSTMs that help you understand uh, NLP, help you deal with time series forecasting problems, autoencoders that help you deal with understanding data, the nature of data, generative adversarial networks like discriminators and so on, long short-term memory networks that again are a offshoot of recurrent neural networks, reinforcement learning, which is a kind of supervised mix of supervised and unsupervised learning for an algorithm to train itself over a period of time. A big application of reinforcement learning has been in algorithmic trading. You would have heard about that a lot. So algorithmic trading is nothing but automated trading on the stock market sites, wherein you allow the machine learning algorithm to carry out trades. Uh, Anything you feel that I have missed on this slide regarding deep learning networks? Anything you feel I can add or talk about? Let me know in the chat. I'll take a brief pause. Somebody asked a question here, sir. I am pursuing post graduation MBA, doing specialization in business analytics, and secondly, you have to make project business analytics field only. Please, sir, suggest me some latest topic for college project. Someone very important, crucial aspect of business analytics is has always been competitor analysis. So for any organization, it is important to understand the competition. Uh, and what the competition is doing to stay ahead of the market. So it's always there's a target market, and your organization is trying to enter that market, and your organization is trying to find opportunities there. So one very interesting use case is how your company can gain a foothold within that target market. What can it do differently to what the competitors are doing? So this is where a lot of digital analysis, like digital marketing, like SEO tools and all, analyzing that is important. You could probably work on a use case for competitive analysis on SEO keywords as to what sort of keywords are being used in social media by your competitors, what sort of adverts are they putting out, what is the target market, who is the niche clientele, and what a company can do to kind of target that same clientele. What can they do differently? That would be a very interesting use case to work on at least. Uh, tech-
What
tech-
is the first rule for freshers to kickstart in the AI and ML field to gain experience?
Uh, so the best thing that you can do to gain experience is first, I'll talk about it in subsequent slide. Actually, I was coming to that. Uh, Let me just address these questions first because they're related to the current slide. As we go on, I'll talk about that as to how you can start your journey inside the AML. I will definitely talk about that. DSA coding is important in future. So I have been very vocal about using DSA as a tool just to crack interviews. The thing about data structure and algorithms is yes, if you want to build a career in data science, they are extremely important. Certain data structures like stacks, linked lists, graphs are extremely important to understand if you are targeting a career in data science. And even within algorithms, like understanding algorithms like back propagation and so on, are going to be imperative for you to build a career in data science. So yes, knapsack problem you would have heard, traveling salesman problem. Understanding all of these problems and solutions to them is definitely greedy solutions to problems. It's important to understand all of that if you want to build a career in data science. So building an understanding of that is extremely important. Having a fundamental understanding. Uh, Solving a problem within 20 minutes should not be the goal, but being able to solve a data DSA problem, even if it takes a couple of days, having a fundamental understanding on how those problems are solved is useful. Yes, you need to know that, and you need to spend time learning that. But if it is your interest to work on DS algorithm, to participate in competitive coding, go for it. If it is your interest, if you love doing that. But for building a career in data science, a fundamental understanding is important. Okay. So I'm currently studying computer science and engineering third year. So tell me some latest topics from making college project. We'll talk about that as we get to later slides. How to get intern or job in field of AIML. I will talk about that. How AI will impact the consultation segment. Our big and are also using it currently. Oh yes, JP Morgan Chase is making a big push towards AIML. They have a lot of strategic alliances with various platforms like AWS and so on to work on AIML platforms. I personally worked on one very important AIML. I'm not at liberty to share. I will be talking about it briefly in a subsequent slide, but I have worked on one AIML problem in JP Morgan Chase as well. So yes, there are a lot of applications that banks, especially like JP Morgan Chase, Morgan Stanley, etc., are working on. There's a big push towards AML, especially building chatbots for their customers. A lot of research is also being done in these companies. There are specialized research wings that work on doing research and analysis on AML. So yes, there's a big push. Which course I'll talk about in subsequent slides. I also wanted to understand whether DSA is important in future or not. I've already talked about DSA. Yes, building a fundamental around that is extremely important. Yes. Let me move ahead in the slide. So this is one slide that is important. So if you want to make a career in data science, these are areas that you definitely need to target to build the fundamental building blocks for the successful career. Because if you are able to understand these aspects, anytime you interview for an AML job, these are areas that you would be interviewed on. So yes, DSA is there, linear algebra, simply because a big application of linear algebra is building your own models where you understand what sort of equations need to be used, what sort of analysis needs to be done, statistics and probability. That is extremely important. Information theory, game theory, calculus, discrete mathematics. These are areas that you definitely need to have a fundamental understanding if you want to follow a career in data science for sure. Any questions related to this slide before I move on? Someone from financial background? Yes, I will talk about that shortly. But any questions related to the areas that I have mentioned here? All right. Let's not move on. So, first of all, these are the prerequisites for getting an AML job. Of course, you need a bachelor's degree in computer science, mathematics, whatever, or uh, a bachelor's degree, as in it could be a BTech, it could be a BSc, and so on. If you want to target senior roles, you definitely want to do a master's or a PhD in mathematics or similar related field like computer science and so on. Uh, and of course, there are also options to do data science related professional certification from reputed universities. But the caveat here is that you definitely need a bachelor's degree, first of all. Please don't think of dropping out. Please don't think that I want to do my startup, so I want to drop out from my college degree and so on. Complete your college degree. It is the biggest plan B that you'll have in your career. Never think that I want to leave my degree and pursue something else. Complete your bachelor's degree for sure, and then decide whether you want to do a master's degree. The reason you would do a master's degree is because if you want to target senior roles in data science, then a master's degree is preferred. Further down the career, of course, any opportunities that you get in data science will always start with an internship. Now, of course, you have asked me, and let me be very clear on this. It is not necessary that you will get an internship in data science. It is not necessarily that you will get a starting job in data science, but that does not mean that you cannot transition into a career in data science. So the first very important aspect is one, get an internship anywhere in data science. Once you have that, once you have secured yourself in terms of an internship, in terms of a job, look for opportunities within that particular organization where you are starting to apply yourself in the field of data science. How will you do that? This is where it is important to start with courses. If let's assume that you have already built a foundation in mathematics and so on. So first, learn Python. And when I say Python, I mean that you need to have a fairly good grasp of the language. Certain libraries like Pandas and NumPy you would have heard of. Build expertise in those libraries. Build expertise in visualization libraries like Matplotlib, Seaborn, and so on. Those are the fundamental building blocks for anybody who wants to transition into a career in data science. So it is imperative you learn this. Python. Forget about R. Python is most widely used. So definitely Python is something. People will also say that we are using C, C++, and so on other languages, but the most widely used language for data science is Python. So learn that. Start with the classical machine learning algorithm. So at the basic building blocks, like for example, you might learn about decision trees, you might learn about your SVMs and so on. Start learning about those fundamentally. Uh, then of course, probability and statistics, you would have heard of Bayesian Bayes theory and naive Bayes and so on. It is important to understand the fundamental aspects of that. Start there. The best place to practice for any data science practitioner is Kaggle. Kaggle has a plethora of data sets in various fields. So you should always start Kaggle, participate in Kaggle competitions. They'll give you a notebook to practice and so on. If you don't have a capable machine, a laptop to practice on, then of course Kaggle is a great place to start. I will be recommending some courses and certifications for you that you should do even at this point to build a fundamental basis for transitioning into a career in data science. Those are wonderful courses. They are worth doing. And a lot of you would already know about some of those courses, but I will still reiterate through those because doing those courses will not hurt your prospects at all. So again, target any sort of internship, target any sort of job first, get into a job first. Don't be hung up that I specifically want a job in data science, I specifically want a job in AI, specifically want a job in AML. Get your foot in the door, get a job first, then start transitioning. Even in AI, there are a lot of jobs in ML ops. Nobody talks about that, but ML ops is nothing but building CI/CD pipelines for your machine learning models, retraining them every day, applying data analytics and data processes to retrain those algorithms. There's a lot that goes into that. So there are a lot of specializations within AI ML as well. It's not just about training models. It's about a lot of data pre-processing, data analytics, data cleansing, data collation. All of that forms a massive part of the data sciences day-to-day jobs. Let me just get to that sheet directly. So again, those are the key responsibilities for any sort of data scientist: data processing, data collection, blah, blah, blah. Some of the unknown things, of course, from this slide, you would know the known things. I will not talk about those because everybody would talk about those. But some of the unknowns is establishing guidelines for data preparation, because data preparation, that is basically forming the funnel for your data. So you get data from 10 different sources. You want to create a funnel for that data to flow into your machine learning models. So establishing guidelines is a big part of what a data scientist does, because it could be that a certain organization does not at all want to look at certain kind of data. You want to ignore that kind of data. So you build a guideline saying that if any point of time, like for example, data about ethnicities and race, largely organizations want to ignore that because you don't want to build that sort of bias in your machine learning models. You would have heard of a recent controversy regarding Gemini, where it had that sort of racial bias. You do not want that. forms a part of the ethics. So you do not want that within your data. So for that, I mentioned ethics also over here, data ethics and privacy. That is why establishing guidelines is important. Identifying use cases for your organization where you would apply ML, because more often than not, if you're working within an organization, they will a lot of people from various departments will come and say, "We don't understand what to do with your data." This is where, as a data scientist, you put on your thinking hat and say, "This is what you need to do with your data. This is how you can apply yourself." Research and innovation, like I mentioned at the start, a lot of people are not looking at research and innovation, but there is a lot of scope for research and innovation in various fields like education, um, even agriculture, farming, scientific advancement, medical sciences, and so on. One of the key responsibilities of a data scientist is to represent the organization when it comes to writing white papers and journals for international accreditation. So you are constantly expected to do some sort of research where you are able to present those white papers in various forums, ARCs, XIV, and so on. So that forms a big part. So you always need to be on your feet and looking at opportunity to explore new areas, and that is where even within your graduation, post graduation, etc., build that research kind of mindset where you're never happy with what you have and you're always exploring new areas for research and so on. So that curiosity always needs to be there. Consulting with companies, because uh, so solving a problem for a company is not just about giving the best solution, it's also about giving the optimal solution in terms of cost effectiveness. So as a data scientist, it's very important for you to understand how the data is going to be used, where is it going to be deployed, what is it going to cost the company, is it even viable in terms of cost, can we come up with cheaper and more alternative solutions. All of that falls under the purview of a data scientist. And of course, evangelizing about the advancements in data science for your company to other forums, other companies, and so on. So you need to become a good orator as well. So if you are nervous about speaking in public forums, platforms, you need to get over that nervousness. You need to build that confidence to be able to present what you're working on in various forums, talking about it, evangelizing it, having people ask the right questions, and having engaging conversations. And I'm trying to have with you right now. uh, Gonna take a quick pause here. Any questions for me? Uh, right. Is it compulsory or one can learn from internet and other sources and these skills? So before you jump onto the internet and start learning, of course, there are a lot of platforms like Medium or towards data science, analytics, vidya, etc., that you can scan to get everyday knowledge. And I would 100% recommend you to browse articles and read articles every day. Yes, but as even as you browse articles, written knowledge is dangerous. So fundamental building blocks are important, which is why going to encourage you. I'm going to be recommending a few courses. Please do those courses to have the fundamental building blocks, because anytime you're talking in a forum, you need to understand the fundamentals behind that conversation. So do those courses, and of course, look at all of these blogs from these various websites. If you can get a Medium subscription and so on, analytics vidya and so on, go ahead and get those, because there are some wonderful articles that people write on those platforms. Um, So in the field of economics as well, there are a lot of like you talk about macroeconomic theory, microeconomic theory, and you would read a lot of data about like compiling statistics, like for example, the number of employable people within the country, the GDP of a country, etc., etc. Certain statistics that are important to understand for a state, for government. So even as an economics graduate, yes, you're always dealing with a lot of data, and for that. You would basically looking at data analysis. So even within data analysis, some of the courses that I will be talking about do talk about data analysis at scale and even within a smaller scale. So yes, to get into data analysis, some courses that I'm recommending you can do those. But over and above that, like I said, one big part of aspect of an analysis is data processing, data collection, etc., etc. So understanding the building block is very important for that. Evangelizing, as in talking about a certain solution that you have built, or talking about a data science initiative that you started, talking about a white paper that you've written, some research you have done. So when you talk about that in certain forums, when you want people to be invested in the ideas that you are presenting, that is what evangelizing means. Mm. Any follow-up questions regarding what I've just said? me jump to one slide and then I'll come back to some of these slides. So let's see. So these are some of the courses that I'm recommending, right? There are a couple of courses from Udemy that are worth doing. The first course is on machine learning. This is the course that I did to get into machine learning in the first place. It's a wonderful course on Udemy, which is definitely worth doing. It will help you understand. It will give you a lot of hands-on exercises as well. It will help you with the fundamentals. There's a course from Udemy on deep learning, but of course, the gold standard for deep learning is always the courses from Andrew NG and deeplearning.ai. That, of course, Stanford is giving. So before you jump to those, do the course from Udemy. It will help you understand data analytics, data visualization, data collation, all of that. It will give you a good hand holding of that. And then you can jump to the deep learning specialization courses. Once you have completed those specialization courses, you would be very well placed to work on actual data learning problems. And that is where I encourage you to go to Kaggle, participate in competitions, look at data sets there, get your hands dirty with some of those data sets. There are a lot of wonderful data sets on Hugging Face as well, especially related to Gen AI. So two platforms, Kaggle and Hugging Face, that you should definitely register on, start exploring, get the data set from there, get your hands dirty working on your own AI/ML problems, and that is how you kind of prepare yourself for jobs in data science and AI/ML. And of course, the learning data structures and algorithms also imperative. Uh, some of the recommended certifications. So, like I said, Stanford Machine Learning Specialization on Coursera, deeplearning.ai is what it's called. Andrew NG has been a big part of formulating those courses. Caltech provides a postgraduate program in data science, so you need to be a graduate to be able to do that. It's an online thing. And similarly, IIT Roorkee and other IITs also as well are giving these specialization in data science courses. These courses are worth doing. I would definitely recommend those. But once you completed graduation, it's worth doing those. I would also recommend that get into a job first and then do these courses. Don't do it the other way around where you start doing the courses first and then start looking for jobs. It doesn't work that way. Please get into a job first and start doing those courses then. And of course, if you want to do a master's in applied data sciences or machine learning and so on, go ahead and do that from an Indian university or a foreign university, wherever you're getting an opportunity, please go ahead and do that. But also over and above, even if you get into those courses, it's still worth doing all of these certifications and courses that I'm recommending over here. Okay. Let me go back and talk about some of the use cases that I've worked on. So I've worked on a segmentation problem. It's a deep learning problem to identify lanes. So a big part of this was the preparation of the data, and all of it had to be done manually. So this is where I say that data preparation, some part of it can be automated by AI itself, but a lot of it has to be done by hand. So people had to actually use tools to draw lines within the lanes so that my machine learning algorithm could classify the pixels and understand that the lane is supposed to appear on a road here. That was a deep learning problem that I worked on. I used a unit architecture to solve for this problem. This was I worked on this problem when I was part of Here Maps. Maps is a location platform, and a big part of the maps that I designed, a big part of the automation is done using AI. So I worked on one of the problems over there. Uh, then in JP Morgan case, of course, I worked on a time series forecasting problem to build client portfolios. I did that using, initially we used a model called seasonal Arima, but eventually we ended up using an LSTM for that problem. And again, LSTMs are long short-term memory modules that understand the holistic context of a data if it's temporal in nature. So LSTMs are a good application of these use cases. That is what we used eventually to work on this. But essentially, it helped clients build their portfolios for certain investment vehicles, even JP Morgan Chase. And finally, one of the other models that I worked on was a random forest model where we were basically trying to decipher that if you reach a certain intersection, then what are the certain directions that you can take. So there were certain rules, and those rules went into programming training the random forest to create a decision as to which route a particular person can take at a particular signal. So within the tool, we had to draw these lines that connected the roads that you could go to. You could go right or go straight. So the line signified which direction you could take, and the random forest algorithm was helping us decide that classification. Okay. And then, of course, in Gen AI, so in generative AI, let me spend a little bit of time talking about generative AI, right? So A lot of you have been reading about the revolution in Gen AI. Every day you see a new model, a new LLM coming in, and the number of parameters it's been trained on, the speed at which it is allowing inferencing, the APIs it's exposing. But fundamentally, do you think you could ever get a chance to work on creating your own LLM? That is going to be very, very, very rare simply because of the cost that is involved, the scale that is involved in doing that. More often than not, what you would be working on is simply called building a RAG architecture, retrieval augmented generation. That is nothing but having a base LLM at the back end and then say creating a knowledge base that helps the LLM derive insights and then finally derive an output of text and generating an output. Maybe like a very good example would be building a chatbot. So you might take an open source model like Mistral, and then you would have a knowledge base that could be a relational database, a MySQL database, or it could be a vector database, where you actually have certain data about the organization. Like for example, if it's insurance products, then you have data related to insurance products stored over there. Like let's say you want to take a term insurance and you want to check your eligibility. So that knowledge base will be built in the database. And when you add your query, it will first go to the knowledge base and check that based on the criteria, what is matching, what is your eligibility. It will get all of that data, give it to the LLM. The LLM will structure it into nice response, and then it will spit that out onto the interface. So you would mostly be building RAG architectures, you would mostly be doing prompt engineering, and you would mostly be working with agents. In a few use cases, you might fine tune your own LLM model. But again, fine tuning an LLM model, I've been working on that recently, and you definitely need GPU instances to do that, and that is an expensive proposition. Unless you have a GPU based desktop or a GPU based laptop where you might be able to do that, but even that is quite challenging. So mostly in Gen AI, you would be working on building RAG architectures and doing prompt engineering, right? Any questions for me at this point? But I've talked about a lot of use cases, so I hope people haven't gone to sleep. uh, I can understand that energies might be low towards the end of the day, but no, sir. Then ask me some questions. Let's hear from you. We're nearing the end of the time, so I would like to allocate some time to Q&A. All right. I mean, if there are no questions, so let me close it out. Uh, if there are questions, you can still post those. But please understand that there are new advancements happening in AI every day. There are new research papers that are submitted. Go through research papers, try to understand what sort of research is happening in AI ML. Learn about the technological advancements every day. A best way to do that is look at new sites, subscribe to new sites, subscribe to various blogs, look through LinkedIn. A lot of people post about new advancements in AI ML. It's important to follow those people and check from time to time what they are posting. I post a lot of content about AI, about my research with various tools and technologies that exist. Um, and of course, even as you get into a job, start looking at the bigger picture as to what the company is doing with their data. Try to look for opportunities where you can raise your hand, and this is important. Whenever you're in a job, always raise your hand and say, I want to work on this, give me an opportunity. If you don't do that, you'll just be sidelined and you'll be working on general automation stuff. You might work on QA or whatever. Always look for ways to automate the job that you're doing, and the best way to do that is learn about data, learn about processing data, learn about automation, and AIML is a big part of it. So always stay curious, always keep exploring, always stay on your feet, and always look for ways to raise your hand and say, I want to work on this. So I just want to close out with that sentiment.
Thank you so much, sir, for your kind information. Sir, we have a few questions like what to do to build up one skill for basics.
DSA, data structure and algorithms, and Python.
Can AI be used in optimizing CPU power?
Optimizing CPU power. So I don't think that AI can specifically be used to optimize CPU power right now, but one field that is about to come is quantum computing. So even within quantum computing, there are a lot of applications of AI. So when you talk about CPU power, maybe allocating processes to the certain cores can be optimized by AI ML for sure. But always remember one thing, that even if you're running AI ML within a machine, it is consuming a lot of the CPU power itself. So it itself consuming the CPU power and then deciding how the CPU should be allocated would be a bit too much. But this is where the role of GPUs come in. So it can be used to optimize the usage of GPUs, right? But optimizing the usage of CPUs, I'm not entirely sure that would be a very good use case. Good question there. But definitely, I'd say that resource allocation would be a big aspect of AI.
Sir, could you please suggest a best name of function which increase accuracy in CNN model?
So there are activation functions and backpropagation. You need to do a hyperparameter tuning when you're tuning CNN models. So when I talk about activation functions, you would have heard of ReLU. So tuning the hyperparameters for that is extremely important. There are a lot of open source tools. I haven't worked on any deep learning email CNN problems recently. That's a good question. Let me get back to you with that. But there are a lot of tools that have come in. In my time, there were not. I had to do a lot of hyperparameter tuning myself, but these days there are a lot of tools that allow you to do that hyperparameter tuning within the back propagation. So I'll have to get back to you on that. But yeah, there are a lot of tools that you can use for sure.
So could you please tell us some optimization algorithm used in manufacturing industries?
I haven't worked in manufacturing industry, so I'm not entirely sure. I'll have to get back to you with that.
Okay,
Apologies if I don't have answer to that question right now, but yeah, let
sir,
me get
one
back
of
to
the
you.
student is saying, if we want to work on problems like these, like real world problems, then from where can we get it?
Start with Kaggle. Kaggle has a lot of real world data sets available. Go to kaggle.com, register over there, participate in competitions, and it will give you a lot of real world experience. Also, if you want to get into Gen AI, then Hugging Face is the place to go.
Okay, sir. Any more questions, students? I believe, sir, no more questions are there.
Amazing. I hope that this session was useful for you. A lot of good questions here, a little bit of homework for me. So, Srishti, expect me to get back to you with the presentation link and as well as some of the questions that
Thank you
people
so
have
much
asked.
for thank you so much, sir, for your time and consideration. We believe
My,
that your
my,
expertise and insight would be valuable to our participants.
Thank you. Thank you so much for giving me the opportunity to speak here, Srishti.
No worries. We will share your LinkedIn IDs. Simran, yes, we will share Ritesh sir LinkedIn ID and PPT to you. Please kindly join our WhatsApp group so we can share all the details. Thank you so much, sir, for your time. Sorry,
Thank you.
for your presentation and your consideration, your time.
Thank you so much. It was a pleasure.
It was a wonderful session, sir.
Yeah. Thank you so much.
Thank you, sir.
Bye, everyone. Have a good day.
Everyone, please join our WhatsApp group. So, any doubt, kindly join our WhatsApp group for certification and everything.